on how to do things, why the things are as they are designed in the last OSM releases, and how to achieve these results yourself. So hopefully you'll get many questions that we can discuss over a coffee in the coffee break later. So that is my hope, that 30 minutes will be more than enough. Okay. So that said, what is the focus of OSM? I mean, at the beginning, it was very simple to define what OSM was, because it was defined as an implementation of ETSI NFV MANO. However, the things have evolved in industry in different places, so the scope has been extended. And now OSM is managing infrastructure in general, platforms and applications across cloud platforms. And that is the current scope. And that explains what you will see here, is that the OSM architecture now includes two engines for working, for deploying things. The one is the engine of imperative operations. This is the classical orchestration at OSM. It's the NFV-like, it's mostly imperative, it's a choreography of steps based on some packages and models, some checks that eventually lead to having something deployed at the other side, right? So this is the classical orchestration, well known here at ETSI. What is relatively new is the declarative engine for operations in OSM. It's a way of leveraging on cloud native technologies, or having a continuous reconciliation plus a description of the desired state instead of dictating every single step of the procedure to achieve that result, right? We will focus on this one today because the other is super well known. You have plenty of recorded material from OSM on the imperative framework, 1 week tutorials for that. So I believe that there is more content than actually needed for this tutorial, but I will focus on the new things. So what do we mean by declarative operations? The idea is that you can define the desired state as data, and you can write it and record it and have authorship, have a review process is needed, whatever that you need, combine it. We will see a lot about combining intents there. And you are managing data. And by some magic, that data is synchronized to the desired state. And whatever it takes will happen to achieve that desired state in the target clause. The magic is that in the middle, you will have a Kubernetes cluster. We'll see that later. But the point is that we need to achieve that this synchronization happens effectively from the sources of data to the actual state at the clouds. On the other hand, this seems to be trivial as a declaration, but it's not that simple. And we will have I'll have a presentation tomorrow explaining why this requires some sort of orchestration of the own intents. I mean, how do you create the data? And how you make that data coherent and maintain a proper governance of that data? That will come tomorrow, but today is a hands-on. So all that you need to know in the hands-on is that OSM will help you to create the intents that will be fed into the data, right? And also, and that is the OSM core. And also, OSM will provide the means to achieve that effective synchronization of the intents and check that everything is happening according to the plan. Okay. In the core, as I said, we are decomposing high-level intents into low-level intents that can be understood by cloud native components. We can create transactions that we can revert, and we can expose an MBI that for some use cases is quite convenient. Here is, as I said, we are creating the magic of that synchronization, leveraging on many technologies. However, it's not about synchronizing, it's about checking that the synchronization happens. So here is, if we double click on the components, what we have, as I said, is we need a Kubernetes cluster in this picture, one way or the other. We will see how the map topologically, but in principle, either you deploy directly to a Kubernetes cluster, or the Kubernetes cluster becomes your proxy for creating objects that represent in something that will happen in a target cloud that is not Kubernetes, it's something else. So you can, in that manner, you can create a full database, you can create VMs, you can create whatever that is not necessarily the Kubernetes related, but you can represent with Kubernetes objects, okay? So once that is said, the point is that the source of truth is synchronized here, and this one is continuously watching that in the target cloud, the state is the one that I want, or perform corrective actions. So far, so good. What OSM does in the role of injection of intents is that it runs them in a transaction, they are injected in the sources of truth, and then OSM watches that things are done according to the plan. So the objects are created here successfully, and eventually the creation of the objects here will lead to changes, actual changes in the cloud according to the plan. So that is also watched by OSM. Double clicking in that mechanism that is important for what you will see later in the demonstration is that we will interact with OSM via NBI from UI or CLI or direct NBI calls directly, and this goes to the LCM. And the LCM dispatches a set of tasks into a workflow engine that in this case is implemented using Argo workflows. It could be any other implementation, but this is the implementation that we chose, and you will see the advantages in a minute. That workflow engine is the one that will be interacting with the sources of truth and will be authorized to change the sources of truth, and those sources of truth will be ingested by the CD operator, or the continuous deployment operator, right? So eventually, those changes go to the cloud, right? The point is that if I change anything manually in the cloud, it will be automatically fixed. So I have a continuous fix of anything that differs from the intent. Okay, so I believe that that is clear. The thing is, how can we do this at scale and with a team that collaborates? How can I reuse assets? Here is where we have blueprints. In OSM, the blueprints are a lot of nested concepts, so I will go one by one. The first concept that we define is the Kubernetes software unit. This is a collection of manifests, sort of, that induce changes in a target cloud. The point is that they can be all the intent, or they can introduce references to other intents stored somewhere else. So you compose an intent from them, but all of them are synchronized together. Okay, so a KSU must be synchronized together. All those manifests, I don't mind if they go to the engine and I synchronize at their own order. The things that there is a upper level concept in OSM, there are the profile. The profile is where I put all the KSUs that I don't mind, then they go to synchronization together, no matter in which order, but they can go together and can be injected together. In a profile is where I can put a collection of KSUs and can define as many as I want. It's free. I can have as many profiles as I want. So far, nothing happens in the cloud. Where happens something in the cloud is what we call the cluster intent. The cluster intent is the key here, either because it's represented a target Kubernetes cluster or is becoming a proxy for a target cloud. In each of the cluster intents, which are a data extractor, as I said, what you have is the predefined 4 layers of synchronization. The infrastructure controllers, which are obviously the first thing that need to be synchronized. The configuration of the infrastructure controllers, that is key. And also, once that everything is ready structure-wise, is when I can deploy either applications, or if I'm in a management cluster, a special type of cluster that is a proxy of a target cloud, I can define cloud resources because now I'm ready, okay? As you see, this is more complex than just synchronizing everything. You need to be aware of the order. for real applications. So here what we do is that we attach the profiles to these layers of synchronization, as many profiles as we want, and one profile can be attached to multiple cluster intents. So I can synchronize a set of manifest in multiple locations. Think of an edge deployment. Okay, so that guarantees that just because we are putting our KSUs applications, namely, in the profiles, they will synchronize in the right order, and OSM will do the rest. Okay, so things will happen. The synchronization will happen in the order that is expected. So far, so good. This leads us to a very complex structure, because in the end, I can manage just from very few application definitions and very few profiles, I can automatically scale to thousands of endpoints if I want to, right? I just need to define some cluster intents that represents the remote clouds. So, for instance, I can in this deployment, what I have is the management cluster. That is something special that is a cluster that is just in charge of injecting, either creating resources in target clouds or injecting in workload clusters the required agents to make those target clusters autonomous. So they watch, once that they are extracted, they will watch my sources of truth. So not all the flows will go through a single point of failure. The management cluster is only making sure that the endpoints are alive, only that. So all of them become autonomous once that the bootstrap process has happened. We will see that in motion in a minute, but just to tell you that the management cluster is there to maintain everything up and running, but not everything is going through the management cluster. And now all once that we've seen all that way of reusing information over and over. So the point is how we create the actual instance of an application, or we create a new element in a target cloud, right? I don't know, Databricks in Azure or Google. Well, first, a few concepts. Since one of the operators that are included here is FluxID, it's good to understand how it works in practice. The structure of FluxID is oriented to create references and dependencies. And this is key for everything that we are describing here. The intents are by definition complex. So the intents in the real world are better to be defined by composition, by referencing other smaller reusable intents. So you don't create full structures over and over. You don't reinvent the wheel over and over, but you compose them. You reference something that is well defined somewhere else, and you say, and I want it here in this deployment, for instance. So I don't need to reinvent the wheel all the time. Also, as you saw, the order matters. So you can define dependencies between layers of synchronization, between KSUs, whatever. So here the vehicle in FluxID are what are the so-called Flux customizations. That are the way to specify both, to gather remote references and to specify if I should wait until others are ready. Okay. In the case of OSM, OSM follows an approach that is quite simple. Is something that is read-only, something that is the runtime. Read-only are the software catalogs. Not read-only, actually, I can add something to my catalogs, my catalog of blueprints of applications, for instance. I can add, but if I add something to that catalog, it does not imply any change in the runtime. Nothing happens in any cloud yet. The fleet catalog is the one that represents runtime, what happens for real in my deployment. And that is where I'm collecting all those cluster intents, all those references, etc., that, of course, reference things that exist in the software catalogs, okay? And it's the runtime intent. It's the actual runtime intent that is creating the composition of intents, okay? It sounds like complex in terms of wording, but the idea, I believe, is clear, is that I'm collecting attributes, and all of them come together, and I tell them in which order it should be deployed. Period. If I have one region ready, I know how to create the second region, the third region, the fourth side, the sixth side, etc., etc. Okay, that is the idea. And And here, if we are talking about reusability, the blueprints are key. There are two blueprints in OSM that are important: the OKA package and the app package. The OKA package is a simplified blueprint that is valid for many applications. Most IT-like applications have enough with a OKA package. It only has one synchronization layer. I mean, it has some restrictions to make it simple. It has an implicit model, so that's why it's simple. The point is that roughly 80% of applications could fit into this model, so the onboarding is very simple. However, if you need something more sophisticated, you have the application package. The application package gives you all the flexibility. You can deploy it over multiple profiles. You can use multiple source templates. You can create custom transformation, anything that you may need. This is essential for deploying complex applications, multi-layered applications, and create cloud infrastructure that has multiple synchronizations and multiple components of different kinds, right? So you have the flexibility to choose any of the vehicle. Actually, one is a superset of the other. Going to from the simple, I mean, the OKE package has two components, essentially what are called the templates, that are a collection of customizations to be parameterized, some indications of what can be changed in them, and a collection of manifests that are read-only. Read-only, but because they will be used by reference. So in practice, when I'm instantiating, I have some input parameters, values, whatever, that are specific to that deployment. Those adapt the customizations from the templates part, and also there are some additional manifests that I can generate from scratch, like secrets or config maps that can need to be encrypted, etc. So OSM will do it for you. And these customizations will in charge, as I said, to reference that other part of the blueprint, the read-only part by parameterization or whatever, but that part remains at the software catalogs. In practice, what happens from the perspective of the cluster is that these two are together. The composition creates the magic that they are deployed together, right? So that maximizes the traceability of what you're doing. The developers are comfortable that things are used as the way that they design them. But in the end, I mean, this layer approach allows us to track where changes have been added. This is the app package. That's the reason why I'm explaining it later, right? Simply because you can have any cardinality of those components, plus these custom transformations, plus a model that explains how these components are related among them. So you have more flexibility, more complexity, right? Of course. Well, these are some of the benefits. I will skip this one because you will have it as part of the background material. Essentially, you have everything that you might need to define a complex cloud native application or infrastructure. So you don't need to create code. So essentially, I can deploy it in multiple locations. I can create multiple KSUs if I need. I can read from multiple templates. Each of the templates can have their own collection of synchronizations and compositions, and they can have different types where I can feed different type of information or even create a custom type. Okay. All in all, what I am injecting is this model, and the picture that I described before is simplified because essentially that model is what drives all the way that OSM works. So it's like a programming language for composing intents. Okay. Also, if this is not enough and you need your custom transformations, I mean, OSM is providing an SDK for you to implement them and include them in the application package. So it brings to high level any of the complex onboarding operations that you may need, including all the encryption, the keeper generation, the conversions between formats, the concatenation of intents, the generation from scratch, the different objects, all the different type of patches that are needed, etc. I mean, there is a full tutorial about this recording in OSM YouTube channel. I will provide the link later because this part is a lot of fun if you are good about coding and cloud native operation. And regarding the installation, which is what we'll see right now, is that OSM installation is modular. Actually, it's intended to have different components. I mean, the core cluster of OSM components plus the management cluster with some of the operators that you need, plus some auxiliary services that could be deployed in a standalone cluster if needed, or deployed as a Git service that you have around, or an S3 service that you have at your disposal, or whatever. So you can choose the components. However, this is super cool for production environments. However, if you just want to test OSM on your own, I mean, there is only one installer. So if you have never tried, this is my my invitation on how to install it. This installer you'll see it in a minute. Will install everything in one single cluster. We'll create a cluster for you, and we'll install everything together. Okay. So, and we'll also install a GitIA in this case inside that VM, so you have your own private Git repository. It does not preclude that you use your own Git repository, but just the easy procedure is this one. It will create all the keys for you, etc. Okay. So let's see in practice. Probably this is what you were waiting for. So I will change the sharing. Here. Okay. Oops. Now. Is this on? Here. Okay. So, so this is the installation. As I said, I mean, there is a one-liner to install, but you can split it in three. Just download the script, make it executable, and run it. This is all that you need. This creates everything that we have been describing for you, including some examples that are preloaded, just for your fun. I will accelerate this for your interest. And hopefully I don't go too fast. Now, okay. So now we have the installation. It takes roughly 5 minutes, 10 minutes, depending on your bandwidth. So now we can check what we have. This is what the namespaces that will install for you, the all-in-one installation. And these are the pods that should be in your cluster. Sorry for this. Here. Okay. Just in case that you want to check your installation. And it will also pre-provision it. So we'll check it, how this is pre-provision. These are the endpoints that have been created for you. Okay, it's creating some endpoints, one for the MBI, this one, and one for the UI, this one. Of course, in a professional deployment, you will not use an NIP.io endpoint, but here it's very convenient to have it, right? Then we will use, so if you want to contact to your UI, you just use that endpoint, and here you are, right? This is as simple as that. If you want to use the OSM client, you just source this file that has been created by the installer with the endpoint and of the MBI, and that's it. It's all that you need to get started. Okay, so you can run a command, an OSM command, OSM bin list, or whatever. Okay, first step. Now, if you have your infrastructure, I mean, let's assume that you just have Kubernetes clusters. Assume that you don't have an EAS, an OpenStack, a Google Cloud account, or whatever. So let's start simple. So we'll create a dummy bin. This is a container in this case, a placeholder to put together some Kubernetes clusters, so you can administratively manage them together. Optionally specify some networking, but that's for advanced use. Here, what we are doing is that we have created, as I said, sorry, because that was too fast. Here I created a placeholder, a dummy bin environment, and here what I did is that I'm registering a cluster, and here is where something actually happens. Is that I'm just passing the credentials of my pre-created cluster. I could create it myself, but it would be very, very long for this demo, so I had to cut it down. So the thing is that we have launched this command to OSM, and OSM is in charge of injecting all that is required so that OSM can manage declaratively that remote cluster. So this process, if we double click, here are the workflows, how they are running. Here is the state that OSM is reporting, and here is the management cluster. So if we say that we have this one running, but eventually this one will create some changes. Now he succeeded. He has changed the Git repository. We'll see it in a minute. And now the Git repository, since it has been changed, automatically infers some changes in the cluster. The cluster realizes that there are changes in the intent and starts creating things crazily, right? These things in the management cluster are the one that are required so that the management cluster injects all the agents in the remote cluster, okay? If I want to add a blueprint, as is simply, let's assume that here we have the examples, so we can clone a few and we can upload some of them using an OKA add, as simple as that. Again, OSM will register it, will take note of it, and will understand the structure. And that structure, well, here there is an analysis of the internal structure of the app package. Probably is too much information, and we have very long tutorials about this, so probably I will skip this part. But essentially showing the contents of one of the packages. But with the figures that you saw, probably you can get an idea. Here, as you can see, everything is parameterized as needed, and you can create a transformation, overlay patches, whatever that you need. Okay, encrypt parameters on the go, etc. The point is that once that information has been added to our Git repository, and we'll see it in a minute, that okay package is succeeded. Now we can see that in our Git repository exists. So now we can get here are the credentials, the random credentials that have been created during the installation. So these changes, so you can check them in this file. So we can go to the endpoint of the Git that has been created in the all-in-one installer. We can access with these credentials. We can copy them, copy paste. We enter and we see that our catalogs now have all the contents of the package that were needed. Okay. And the OKA is successfully registered. So now we will do something in the cloud. So now we will be instantiating an application. No applications have been deployed, just checking. Here we'll have the parameters to make things briefer. Essentially, you can pass custom parameters so that the deployment in the blueprint makes sense, right? So you can change the password of the deployment or something. So here you have it. The command is something that is interesting, that you have two types of parameters that can go unclear in the cluster, and parameters that must be encrypted. Okay, these are the secret parameters. All of them are kept encrypted during all the process. Okay, the application is instant, but internally they behave as they should, but some of them are treated so they never land in a Git repository or in a source of truth. They are managed totally differently. So say that we have the deployment, and if we check the deployment, and I'll go slowly because this is the end of the demonstration. We are in the fleet, in the runtime, and all the manifests have landed here. Okay, the manifest has landed here, and as we will see in the target cluster, our application is still reconciling, you see, because it's still being deployed. Although I've changed the intent, the data has not been percolated to the cloud. The cloud is getting the information and transforming itself. So in a few seconds, we will see that here all the now we have it deployed. Okay. Let me see it slowly. Here, the application is reconciling. and eventually it should be ready. Now it's ready, okay? So the Jenkins application is ready, so it was deployed and is available, okay? And it's deployed in the target cluster. Okay, 30 minutes more or less, roughly. This is not, of course, this is not a full tutorial of what OSM can do for you, not even the declarative framework. Actually, we have plenty of material of sessions like this where we have been focusing on different aspects of the declarative framework or the good old NAV-like imperative way of operating. All of them are available here, so they are a convenient slide for having getting the contents and pausing the contents and seeing how it works. Okay. So that is all that I have. So that's it. Hopefully that is whetting your appetite for trying OSM, for asking us questions eventually. So thank you very much for your attention.